this is kind of one of those fun things that I get to do. You mentioned in the intro the podcast I'm on. So I'm on a podcast. We call it FGGBT. It's Fascinating Gadgets, Gizmos, and Gear-Based Technology. And we do exactly what you just said. We take fictional technology and science and make it a reality. And tying this to us dating ourselves, we did a fun episode. The other two guys on it, Daniel J. Glenn and Ben Siepser, are younger than me. Let's just say that. So one of our episodes was basically, Mike, you're the old one. You're closest to death. So if you want to prolong your life and make it better, do you do it by technology or do you do it by biology? Right?
Welcome, everyone, to another episode of Into the Pit. And I'm very privileged to have Dr. Michael Dennin here with me. He is an author and also has a podcast, and we're going to learn about those. And first, tell us a little bit about yourself.
Sure. Well, first, great to be here. Thanks for having me. And, I am a professor of physics at UC Irvine. And it's funny because our department's physics and astronomy, and I study bubbles and foam. And when I use the full department name, people think automatically that I just study astronomy. I love astronomy and I'm involved because people may also recognize my name from having been in Ancient Aliens a lot. So interestingly, in that, I'm usually talking about the physics of materials or the physics of relativity, not so much the astronomy, but it's fun to do. But my whole career, I've just loved talking about physics in various public forums and in different ways. And early on, I got really lucky to get involved in talking about the physics of various superheroes.
Oh.
And, one of the things that I tell students, you never know where your career is going to go. I mean, my paying job is being a professor. But because I did this fun thing of looking at the science of superheroes, I actually developed a course on it. I got discovered, as they say, right, by a production company, and I got to do a great series of shows way back when for National Geographic and the History Channel, The Science of Superman, Batman Tech, Spider-Man Tech, and Star Wars Tech. And you can still occasionally, I think, find them on YouTube, or they occasionally repeat. But that really just started a real, interest in going even farther with that. And it's the same production company that then did Ancient Aliens. I now occasionally interview for them on Unexplained Phenomena. And so it brought me into these areas that I think physicists, we often, we stay very focused on our research. We have to do our teaching, and you can be very kind of in that sphere. And this has really helped me kind of branch out and do just a wide range of stuff. The last thing I'll say is I joke, I describe myself as the person who will talk about the physics of X, where X is anything except politics.
Oh, good. Let's stay away from that subject.
Yeah.
So how is it Superman can fly?
So this is the fun thing. I learned, so I was a kid of like the 70s. Yep. And I'm not a comic book reader. I was like a Saturday morning cartoon people. So my knowledge is, the Justice League, Spider-Man cartoon, Batman and Robin from the 60s. So my knowledge of superheroes is kind of in that space when I started this. But when I got into it, Superman is like a fascinating superhero to me because the original Superman couldn't fly.
Right.
He could just jump really far.
Mm-hmm.
And right. So when you think of it from a physics point of view, okay, that is a super cool idea, right? If you were designed for a planet with way more gravity and now you're on Earth, yeah, you're going to jump far. Just like when the astronauts went to the moon, they could jump higher. And you have to sort of be careful of things, and you want heavy boots, and you don't want to accidentally, be on too light of a planet and float away. But then you get to the point where he flies. And what I love about him flying versus some other things superheroes do is it allows me to give talks with a great first question. I say, how many of you think you can fly? And I trick them, like I hold my hands up in the air like I'm going to fly like Superman. And nobody raises their hand like, oh, we can't fly. And they say, how many of you been in an airplane? And they're like, oh, wait. I'm like, yeah, that's what we do. We ask trick questions. And Superman just needs to get lift and he can fly. And so you can start having fun conversations about, is the cape what gives him lift? You know, if he runs fast enough, is that like an airplane, you know, and he gets it? How does he get thrust once he's in the air? Is he flying or is he gliding? And, you know, depending on the age of your audience, the source of thrust can range over lots of different biological activities and ways of expelling biological materials. How's that for a scientific way of saying it?
That's interesting.
Yeah. I mean, my favorite moment was I was talking to grade schoolers and I said, how does Superman, you know, generate thrust? And some little kid just shouts out, he farts. And, you know, in a grade school context, he almost got in trouble and I had to kind of protect him, you know, from the teachers. Cause I'm like, I get for some people, you know, for grade schoolers, you don't want that because that can go bad real fast in a bunch of grade schoolers if you start going down that route. But I'm like, scientifically, it's valid. That could be a source of thrust. And so it's a fine line to navigate.
I wouldn't want to be behind him when he does it though.
No, exactly. Exactly.
Oh man. So Saturday morning cartoons, Ted Knight. Ted Knight was you know, like my favorite announcer because I knew Super Friends were coming on.
Yep. No, I mean, I just remember, it's funny, and I try and explain this to my kids who are just young enough. I mean, my oldest, you know, lived through having to watch commercials and you couldn't fast forward through everything, but barely, right?
Right.
And now, you know, what is a season? It's often like part here and then you have reruns and then you have the season, like, or now it's streaming and all drops at once. But, you know, I remember September, like early September, the Saturday morning cartoon preview shows.
Yep.
Like that was almost as good as the shows, right? You'd sit there and you'd be like, okay, what? And you're planning out your Saturday morning.
Oh yeah.
And your watching schedule. Cause you know, the different, you know, there's only 3 stations, but that's still 3 things competing with each other.
That was like the best whenever the preview show would come on. It was usually the night before.
Yep.
And also whenever the TV guide came in the mail and you say, okay, well, I'm going to watch this station first and then get up and move the rabbit ears and, you know, switch the little terminals in the back.
Yep. I think we just lost half our audience, Kyle, but you know. Why do they have a rabbit on their television?
Right. Hey, that the things we had to go through as children, right?
We did. I mean, but what it was also kind of, I will tell one personal funny story as I got older. You know, my parents claimed that, you know, they said we can only watch so much Saturday morning TV. I think it was like an hour or an hour and a half. And so we had to plan it, right? And I remember my brother and sister and I doing all sorts of things. One is my parents would sleep in, so we didn't count any of the time while they were asleep. Like we thought we were being so clever, right? We'd get up early and we'd watch. And then we're like, well, if I'm watching a show and I kind of don't like it and you picked it, that's not part of my hour. That's part of your hour. I'm just in the room. I'm not really. So we would try and figure out like, okay, you claim to like that show. I'll claim to like this show to get extra time. But I had this realization when I had kids and I'm kind of sort of mimicking my parents' rules. And I called my dad one night. I said, Dad, I finally figured it out. You didn't care how much TV we watched. You just didn't want us to wake you up. So you said it was an hour of TV only. So we'd be quiet, hoping to get more TV. And he goes, yep, that's exactly it. You caught me.
Well, I was fortunate enough that my mom let me watch till noon. So
okay, so you were all good.
Yeah, I usually got up about 6 o'clock because that was when they first started, right after the Pledge of Allegiance.
Yep.
Yep. We're dating ourselves.
We are. It's a different TV watching style now. Let's just say that.
But I always wanted to be Steve Austin.
Oh yeah.
So I figured, you know, I'd get bionic parts and I could be strong that way.
Well, you know, one of the cool things about that, just briefly to not only plug UCI, but other places, it amazes me to have lived to a point where we're actually building those now.
Right.
You know, I mean, obviously, this is the other fun thing about using fictional situations to discuss science is you get to talk about interesting aspects of it. So when you think about lifting, pushing, moving, running, what's often involved is not just your pure muscle strength. It's things like friction with the ground, right? So if you're going to push something and the ground is slippery, it doesn't matter how strong you are. And we don't worry about that in the fictional versions of superheroes, but it's like critical for football. Like anyone who's been on the line in football knows, yes, it's how strong you are, but it's also, do you get leverage on the other person? Right.
Yeah.
And who's doing it right. So when you think about Steve Austin, you know, just giving him bionic parts isn't necessarily going to make him stronger in all situations. So where does it help and where does it not is a fun thing that I get to talk about. But it's super cool that we have figured out how to connect, you know, electronics with the human brain. The human brain is flexible enough to send electronic signals that a computer can interpret, and you can control a robotic arm. And that breakthrough has, I think, been life-changing for so many people, and so many more down the road as we get it cheaper, more efficient, and better working.
Yeah, I've read some kind of article on social media, and mind you, it's social media, so I don't know how accurate it'll be, but they're making predictions for the future. Like there'd be a certain decade where people would actually go in and want to get these parts and change out, you know, their arms and legs and all these, and that there would come a point where you would have a chip put in your head and you could download basically information from this chip.
Yeah,
So,
no, I think definitely the parts is coming. The interfacing directly to chips with your brain is going to be a problem we solve. It's probably farther on. You know, this is kind of one of those fun things that I get to do. You know, you mentioned in the intro the podcast I'm on. So I'm on a podcast. We call it FGGBT. It's Fascinating Gadgets, Gizmos, and Gear-Based Technology. And we do exactly what you just said. We take fictional technology and science and make it a reality. And tying this to us dating ourselves, we did a fun episode. The other two guys on it, Daniel J. Glenn and Ben Siepser, are younger than me. Let's just say that. So one of our episodes was basically, Mike, you're the old one. You're closest to death. So if you want to prolong your life and make it better, do you do it by technology or do you do it by biology? Right? Do you go the route of, you know, replacing parts with robotic things, or do you, I mean, our genetic engineering and our medicine and our biology is also getting better, right? Both are improving. And you know, sort of psychologically, which makes more sense to you? I will not reveal the direction I pick to prolong my life. I'll force your listeners to go listen to the episode on our podcast. But those are the kind of fun things we do. And I do think it's going to be an interesting world when we as humans get more choices, you know? I mean, I don't know how we're going to handle that, how we're sort of designed for doing that or not doing that.
do you think that we'll actually be able to download our conscious into a computer?
That is a tricky one. Kyle, and you're being so nice to me. So now I can plug my book. So my book is Divine Science, Finding Reason at the Heart of Faith. So one of the other things I'm very interested in is the intersection of science and religion, science and faith, and what I call sort of the physical and the non-physical parts of the world. And consciousness to me is a really interesting thing. And the older I get, the more interested I get in what is my consciousness and what's going to happen to it. Because on the one hand, you look at it and naively a computer looks like your brain and you could do it. I mean, certainly downloading our memories into a computer, I have a feeling is something we'll be able to do, but are your memories enough to make it your consciousness or you? I think is a really, really interesting both science and philosophy question. Like, your brain is like a computer in many ways, but it's also not like a computer. The way your brain calculates, the way your brain, you know, even just the fundamental physics of doing it through electrochemistry versus doing it through silicon chips, you know, that could be a physics difference that determines whether a computer can support consciousness or not. So I certainly don't want to be the first person it's experimented on with. Let's just put it that way.
Well, my question is if that was possible and you could basically live forever, would you really want to?
You know, I'm with you on that. It's kind of this weird, scary question, right? Of how long would you want to live? And I know part of it depends on, what do you think is the core and what comes next? And I am a person who thinks very much that there's sort of a core, call it a soul, just because there's not another good English word to it, non-physical part to us as humans that actually exists after we die. I don't know what it's like. I couldn't tell you what exactly it is. Analogies I make from physical systems are, we know about matter and antimatter. When it annihilates, it creates light. But there's core things that survive. The charge is always conserved. It's both before and after. And I use this analogy of, being alive and having a body is being the electron and the positron, being dead and being in the next stage is being light. It just sounds very poetic and nice, even though it's physicsy. But there's a core that goes through. So if you were then to move yourself into a computer, like, do you miss out on something? Right? Or is it not really you in a weird way? And again, or does it just get boring?
Yeah.
Right? And that's a reason we're here for a finite time, is we don't know it, but there's something next that's different and interesting in a different way. So the tough thing is we can't by definition, we can only study physical reality easily through physics, hence its name. And so understanding what might else be out there is just really, really hard to do at this point. It's more sort of guess and intuition than it really is study and careful experiment. So
yeah, I wonder if you would still have feelings like empathy or anger and love.
Yep.
Yeah.
No, it's and also because those we know are both connected to how our brain works, but also maybe connected to other elements. And so if you were to just upload into a computer, I agree with you, there might be things you lose. Like I said, at the core, you would probably have memories, but how does that even work? And there's so many TV shows lately about uploading people to computers or memories or other things like that. It's been fun to think about. I think a lot of them pose some very clever questions.
I'm assuming you've seen that movie, the updated version of the Time Machine.
I missed that one and I really wanted to see it.
It's actually a really good movie.
Okay, good to know, because it's on my list.
Well, watch it. I
Yeah.
highly recommend it. But there is a point in the movie where the main scientist, he's in the future, and then there's a computer at this library, and he runs into it. He talks to the three-dimensional figure that's, I guess in the computer. And then later on, he runs into him again when the world's kind of falling apart.
Right.
And here's this three-dimensional being that's come from this computer, recognizes the guy and says, "Hey, didn't see you before." And he's been in this dilapidated building for all this time. And you think, if he had feelings, how bored would he be, and how would he be longing to just be ended?
Well, I think that's right. And then it raises this interesting question of, I guess eventually the power might run out or the computer might break, but what are your weird options once you've put yourself in a computer? Where do you go from there? Right. And I've grown up, I've read science fiction and fantasy my whole life, and I love that. And it is something that so many different writers have speculated on, right? How long could you really live and be happy? I don't know how many people are watching. I'm a Tolkien fan, so I'm watching Rings of Power. And it's just reminding me of all the stuff. Like, it was very interesting in his Lord of Ring book that you have the elves who are immortal and the humans who are not. And he talks about the pros and cons of both. You know, at first glance, the elves are like, ah, these poor humans, they die, right? They don't
Mhm.
have to deal with that. But the humans are also so much more creative. They're so much more adaptive. They do so many more interesting things because there is a finite time associated with it.
Right.
And so, you know, maybe it's just putting a rosy picture on the fact that we have to die, but it is an interesting, you know, way to look at it.
And speaking of time, how close are we to actually having a time machine?
You know, that's my two favorite questions are how are we going to see all the stars and when are we going to have time travel? For similar but different reasons. One is so like time travel from a straight physics point of view is a fascinating thing because general relativity, when Einstein came up with his theory of understanding gravity as space and time together and that you can bend space and time, we suddenly had a way within physics that you can imagine doing time travel because there are real physical solutions to our understanding of gravity that we call closed time-like curves, where you really literally go in a loop, start at one point in time and come back. So physics doesn't make it impossible from that sense. Now, we don't know enough about general relativity and quantum mechanics yet to know, like, is there another thing that prevents it? Does energy conservation prevent it, for instance? Is there just not enough energy in the universe to do this, or things like that? Also, the other weird thing is, like, it's also a little unclear how time is really working in the sense of, if you think about space, we
Mhm.
understand that if I leave my house and I turn around and go back, I can get back to my house,
Mhm.
right? And in a sense, my house is still there. I could also go back to that same point in space, but maybe somebody knocked down my house, right? Maybe it's not there.
Right.
More dramatically, you and I could meet in the park. We could both leave. If I go back to the park, just because I went back to the park, you're not there anymore. You may have left too,
Mhm.
right? So time travel in physics is a little weird like that. Like, I can go back to a point in time, but I'm not guaranteed that all the particles and things that were there the first time I were there are also at that point in space. I might still need to go find them. So
Mhm.
that's a little weird. So when we ask how close are we to time travel, I'm like, we shockingly have a space in physics we can ask questions about, like, how would we make it happen? And as soon as you can ask questions, I feel like you've got a path forward in science. Um, they are so vague. If I was to use, you know, sort of analogy to the past, I would say we're hundreds of years away from it.
Mhm.
Um, but also we're suddenly making computers that are much better. So maybe that makes it shorter. We can figure things out faster. That's one way of looking at it. The other piece for me for time travel is, we do know what the big problem is. Most of what we do is based on electronics. Like every almost all the innovations we have are just making electronics better.
Right.
And what people, I think, don't always understand is that is because there's both positive and negative charge. And because things can both attract and repel, it's really easy relatively to control and manipulate and do exactly what you want. So all of our modern technology from electronics comes from the fact that things can attract and repel. Gravity only attracts. So if you want to get time travel, the only thing we really know how to do is to control gravity. That's the theory behind it. But because it only attracts, it's very hard to figure out how to control it. So that's the other piece that would put it far in the future. Now, there are people who say, well, we know it never happens or we'd see time travelers now. Um, Not sure, because we just don't know what the rules are going to be. So, you know, I don't take that as definitive proof. But then I'm an optimist with anything that sounds really fun, and time travel sounds really fun. So,
Right. Well, you know, from my little bit of knowledge in Einstein's theory, I can understand how we could move forward in time,
yep.
but I don't know how we would be able to move backwards in time. And then you also have to wonder, is there going to be some kind of object in the way when you're traveling that
Yep.
would mess things up?
No, exactly. So, and the forward in time, as you said, is straightforward. Particularly, like, relativity tells you as you go closer to the speed of light, your time slows down. So you can, and we know how to travel faster. It's just we can go back to Superman, is throwing more stuff out the back. The faster you throw stuff out the back, the more you go forward. So yeah, forward in time is way simpler, as you said. I joke we're always time traveling. Like every second we go a little bit more forward in time. And that's where the backward in time, as you said, it's a whole different type of physics. It's bending space and time. It's massive energy. And again, it's not clear, even if you start to do it, are there structures that get in your way? What does it look like? A lot of people have heard of the idea of wormholes, right? You've got a black hole at one end and a white hole at the other, and they connect. Wormholes are the obvious structure, but everything we know about wormholes right now, you would be crushed entering it. So not a very good way to travel.
Right.
Actually, I should say stretched and pulled apart. So, destroying yourself in the attempt to go backwards in time does not achieve anything. So, your particles might end up back in time, but not you.
But not you, right? Well, and you think if you're going the speed of light, what those G forces would be on your body. I mean, it's already hard enough on, airplane pilots and astronauts and things like that. So what would it do to you? And isn't it your mass gets like heavier?
Yeah, no. So the nice thing is, we get saved a little bit about the difference between speed and acceleration.
Mhm.
So if you do it slowly enough, you don't have to worry about the G forces. The mass part is kind of interesting because you and your ship all increase in mass together, and you don't really notice it internally. It just means it takes more and more energy if you want to go even faster, because the more massive you are, the more energy it takes to go faster. So that limits sort of how quickly you can get up to high speeds and take advantage of time slowing down. So there are limits, but if you do it right, it's shockingly safe. It just takes a little longer.
the problems we run into, right?
Oh yeah. But the going forward and the traveling faster is why I think traveling in space is going to be solved way sooner than time travel. I do think, and this is the interesting thing, and I think it's why for people thinking about aliens and life forms elsewhere, thinking about the universe is so interesting. And we have this whole new, the latest James Webb telescope that went up. I mean, our ability to detect, see, and understand planets that are out there is just jumped magnitudes forward. And my very non-scientific view is we are clearly going to figure out how to travel and colonize space, because if not, that's a lot of wasted space out there that was not needed for anything.
Right. Do you delve any into string theory?
So I don't study it. I like trying to stay on a little bit on top of it.
Mhm.
And because, for the most part, the big challenge in physics we always like to talk about is we understand gravity and general relativity, and Einstein did that. And we understand small things in quantum mechanics, and a lot of people worked on that. We don't know how the two go together. And so string theory falls in this category of an attempt by physicists to figure out how to make gravity and quantum mechanics work. And the interesting thing about it is, I mean, I don't know, it started when I was an undergrad, really. So we won't say how long ago that was, but we know I was watching Saturday morning cartoons. So, so it's been around, and it really hasn't had that smoking gun sort of thing happen. Most physicists are at the point where they think some part of string theory clearly is sort of right about how the universe is fundamentally structured, but we just don't know how much and what. And so it's in an interesting state. But for people who don't follow it much, it's most weird and interesting thing is that the universe is actually more than the three space dimensions we're used to in time, that there's these really small curled up dimensions that also make up part of the universe, which I can barely picture 3 dimensions in my head. So trying to picture additional small curled up ones never seems to work.
Yeah, I always wonder if there's other dimensions out there. And I'm a paranormal investigator,
Right.
And everybody's always asking me what is a ghost, and sometimes I wonder if it's not someone from another dimension, and somehow we're kind of meeting up at the same time, per
Yeah.
se.
No, I think, anything like that is, um, it's a very interesting question of, so when we think about other dimensions, it's an interesting challenge, partly because in physics, we use the word other dimension literally for like directions to move in. So space is three-dimensional because we can move forward, backward, left, right, up, down. If you also could move in a fourth way, then space would be four-dimensional. Usually, and that's what string theory is worried about, is other dimensions you can move in. And those, when I think about kind of either the paranormal phenomena or other sort of difficult to explain things, I don't think those dimensions are necessarily going to be the ones that are relevant. But there's another dimension in another sense. We have a pretty good, again, this is something we can't measure directly or test yet, but it's pretty reasonable to think that the universe started, all of space and time as sort of a fluctuation in what we call the quantum vacuum, right? Like the way I describe it to people is, imagine a field of kids all trying to blow up balloons. And so they get a little bigger, a little smaller, a little bigger, a little smaller. Those are all mini universes. Some kid finally figures out how to do it, and that balloon growing is our universe. And that's space time for us. So now imagine there's another kid who also figures out how to blow up their balloon. That's another space-time universe. And this is one idea of kind of the multiverse. I think those other universes could potentially be the dimensions that you're talking about, where you could imagine they get close to each other in some way, right? And
Right.
things could interact somehow between them. And sort of working out what that would look like, working out the physics of that, what would that even mean? Is something I don't really know that there's anyone working on actively, but it is an area worth thinking about and looking into. So that's one way. The other thing I mentioned is I'm very, very interested in sort of the non-physical and physical reality and how they would interact. That's another way you could sort of have these interesting interactions. And that's something I'm very interested in from the perspective of free will and consciousness as a person. But you can also think of the non-physical and physical, for some of these other kind of effects that we're trying to understand.
And I mean, would it be possible that, that's just a different frequency or vibration, and we're actually all occupying the same space, but at a different vibration?
So that is an interesting thing from a couple of perspectives, because, it was pointed out to me recently, in an interesting way, our physical body and our understanding of physical reality is probably not accurate in the sense we normally think of accuracy, right? Because our body is like a piece of detection equipment, and our brain is an interpretation of those signals, and it's evolved to do it in a way that keeps us alive. There's some great work by a number of people who point out it's not evolved in a way to give us truth. It's evolved in a way to keep us alive. Those are kind of not necessarily the same thing. So to your point, right, if there were other sort of physics happening, that didn't impact us negatively, we wouldn't need to evolve to detect them or interact with them, right, on a regular basis. But you could imagine that you would occasionally experience an interaction with them in a way that was kind of like, okay, now your brain doesn't really know what it is, and it's just going to have to interpret what it is. And so you get a sensation in some context. And so there's that mismatch. So I think, a different vibration is one way to describe it. But just kind of that sort of physical, I mean, the way we would use it in quantum mechanics, the wave function describes the probability of stuff happening, and we detect that with our measuring systems. There can be stuff happening that we're just not normally detecting because it's not relevant to us. And then you detect it occasionally.
Wouldn't it be incredible though if you could change your actual vibrations and you would move into another reality?
Well, and then I do wonder, this, one of the challenges when thinking of a lot of the things in this space, what I run into as professor of X, where X is all things, not politics, right, is it's always a little frustrating to me because when you start speculating, a lot of this space does have actual, people who are trying to take advantage of people who are actual charlatans, right? And so unfortunately, when you work in a space where there are people who aren't honest actors, they tend to get the focus, and it makes it harder to speculate. But one thing that I always wonder about, for instance, I'm fascinated by dreams, right? And is something happening when we're dreaming, or something happening, when for people who have certain, we describe it as mental illness, and a lot of it is real, and I don't want to, sort of minimize the challenges of mental illness, but is some of this, your brain as an interface is detecting a different set of things in reality, and we tend to declare that as false.
Mhm.
And when I think about these people who talk about evolution, I wonder sometimes if it's less a question of false and true and more dangerous to yourself and not dangerous, right? So like if you're having what we would call hallucinations, then yes, you could do something that caused a danger to yourself, or you could be a danger to someone else. But it doesn't necessarily mean that there isn't some truth to what you're experiencing. It just means you've crossed over to it not being useful for survival. And so to your point, how much control do we have over our body and our brain as a detection system, becomes a very interesting question.
Yeah, I talked to a lot of people that their focus is on changing their vibration, and mostly it's manifesting positive things. But
Right.
if you could actually change your vibrations to detect another reality, dimension, whatever you want to call it, man, that would be so fascinating. You just like a switch.
Yeah, no, and it would be, but and it really does get to some of these sort of metaphysical and philosophical questions of what's real, what's not real, right? How so in if I put on my straight physicist hat, and my super skeptic hat, right? We're made of a particular sort of quantum wave function that has stability because of the way all the electrons interact,
Mhm.
right? But if you get down to the level of a single electron, it's kind of an interesting thing. What is it really? It's this wave function. It's a probability cloud. It never really has a definite position in energy. And so when I put on my sort of, I'm going to really think about things like broadly hat, right? There's this big gap between going from the quantum mechanical to us as physical things that really believe this is it. Like it's our body, it's real. This is the only reality, and that's all it does. And so there is that strange, interesting space in there. And I do often think about what can we control in that. And I'm going to come back to this other example. One of the reasons I'm so interested in the non-physical and free will is if we think about, so I study a lot of foam and bubbles. So literally shaving cream, I study foam. And the fun question I get to ask is foam a liquid or a solid? Now people pay me for this. Trust me, your money is well spent, because the question of whether a foam is a liquid or solid can be the difference between life and death, because if the foam doesn't flow when it comes out of the fire hose, it's not going to put out the fire on your house. So if the engineers get it wrong and the foam in that hose is solid, not liquid, big problem. Anyone who deals with grain silos in farms, grain silos can build things called bridges. They can get what's called jammed. And then a very fine flour dust will develop that's highly explosive. And you can look up in YouTube and videos, these grain towers that just spontaneously exploded because the flour powder got too hot. And so on the one hand, people are like, oh, you just study whether foam is a liquid or a solid? I'm like, yes, that's what I get to do, but it actually has these real implications. But what you find is when you take a collection of bubbles, the state it's in, whether it's flowing or solid, has to do with the internal rules and structure, but it also has to do with what happens at the boundary. So if you think of shaving cream, if it's just sitting in your hand, it's a solid, it holds its shape, it doesn't flow. But if you spread it on your face, it flows. And that's what we call in physics a boundary condition change. So one thing I think I'm really interested in figuring out how you would actually study as a scientist, but it is a clear mental picture of things. The physical world is clearly got a boundary with the non-physical world. Now, that's assuming the non-physical world exists. You could assume there is no such thing as a non-physical, but I think that's a better starting assumption than that it's not there. There's lots of things we know of as non-physical. So you can imagine that part of what happens and what you get in the physical world depends on that boundary and whether it gets changed or not. So for me, an interesting way to think about free will and the choices we make is your brain is all chemistry. It's all physical things. It's doing their stuff. And if you want to do something fundamentally different, humans, I would argue, have the unique ability to shift that boundary between the physical and the non-physical in their brain to then be in a new physical state. So this is really like metaphysical and spooky and creepy and stuff. But what it comes down to is if you were doing brain chemistry studies, you would never see the laws of physics violated because your brain is just doing something physical. But you would see a change from A to B, and you couldn't point to a physical thing that changed it because what changed it was the boundary condition. And that's what we do all the time with our foams. You're studying the bubbles, and if you just look at the bubbles, they never break the laws of physics, but they suddenly go from fluid to solid. Why? Because you did something way far away at the boundary. So to your point of changing our vibrations, right? Can you take this even beyond just your choices and free will and use some idea of the boundary between physical and non-physical to do other things to the physical world? So these are the crazy thoughts I end up with, Kyle.
Hey, I have pretty interesting conversations like that all the time.
Yeah.
One is, I have this belief of free will, but predestination at the same time. And the way I explain it is imagine if you had one of those books and it was your life. And the book, you remember those where you would read so far and then it'd say, turn to this page, or you turn to this page. And, but it's already determined what's going to happen if you choose this page. And it's also already determined if you pick this page.
Yeah. So, no, that's interesting. That's actually, that's a clever way of talking about the two. I do think, another thing I definitely say is I firmly believe we have free will and choices, but they're clearly constrained, right? They're not infinite. And going back to my flying example with Superman, I can't just choose to suddenly float off the ground.
Right.
I know that's a trivial example, but I do joke, but I can choose whether to eat chocolate chip cookies or broccoli.
That's true. I'm picking chocolate chips every time.
Yeah, exactly. All the way.
Well, and you're right. When you make a decision, say you're at a four-way stop, you might be able to move a little bit at a time, and there's quite a bit of choices, but eventually those choices are going to run out. Yeah.
No, you'll be somewhere or you're not. And so it's an interesting space. And I do think, one of the weird things about it, and this comes back to the time travel, right? From a physics point of view, there is a very real sense that you could think of all of time has happened. And we're just moving, like we're moving through it. But your book analogy is a great one. The other great one is a movie, right? Back when movies used to actually be printed on things and not just digital.
Right.
You would have you'd have the whole movie, right? You could either look at the whole movie at once, or you would play it in a projector and see it a frame at a time, right? And in principle, the people in the movie are experiencing it as it goes along, yet you as someone outside the movie. And that to me is like one of the really interesting things to play with, is this idea, and this is where the non-physical comes in, right? The idea that the physical is there, but there's also this non-physical that has a boundary with it, right? There is something that happens without time and is all time at once. That's an intriguing thing to me. And it goes back to, putting our consciousness in a computer. Like if I have the option, there's a philosopher at UCI, and he's done a lot of work with what he calls conscious objects. And he's the one who's talked about reality, physical reality is really more about evolutionary survival, not accuracy. And really we're a bunch of conscious objects interacting with each other. What do you get to do when you're done with this physical body and you're a conscious object doing something else, is kind of another fun idea I have to play with.
I had an interesting conversation with someone the other day. We were talking about past lives and that kind of deal. And I wonder if time and all that is really like a ring. There's no beginning and no end, but it's constantly moving in that loop. And so is there a possibility that maybe you're kind of catching up with yourself again, and that's why you have deja vu, or somebody's able to predict the future? They've actually already seen it, and they're just kind of catching up with their body again.
No, I mean, and that's where, on the one hand, so one of the things I always explain to people about science is, what science is ultimately about is repeatable experiments. So when scientists talk, we like to talk about the things we've done experiments on, right? And so this is why, if you look back, even as recent, 80s and 90s, a lot of astronomers wouldn't commit to the fact that there were any planets outside the solar system. Why? Because they just hadn't been measured yet. Really, if you pushed anyone, we all knew there were planets out there. But when we're being sort of very loyal to science, we don't want to commit to something if it hasn't been observed. Well, now, of course, we're observing them all the time. And so people are talking about them, studying them, doing them all the time. There is also what I would call sort of the theoretical space of science, which really crosses over to philosophy more, and metaphysics. And to your point is, Einstein's opened up this world where, okay, understanding the structure of space-time itself and understanding, in my mind, the connection between non-physical and physical, you're exactly right. I mean, what if there are these space-time loop structures? And then quantum mechanics does some interesting stuff with interference and multiverse. So again, to shamelessly plug, these are the fun things we do in our FGGBT episodes on time loops and time travel. So all people have to do is go to fgbt.com, FGGBT, I should speak clearly, .com, and they can find the various episodes of what they want to do as time loops and time travel. But there's that loop idea, Kyle. There's also, in my mind, if we really are conscious objects that are fundamentally in the non-physical, and we just insert ourselves through these bodies as interfaces in the physical, is there anything to prevent a particular conscious object from interacting with the physical world twice or three times through different physical bodies? So these are harder, like these aren't really questions science can easily answer. And again, I think that the challenge in this space, I heard a great quote by someone, and I have no idea, I wish I knew who said it so I could credit them. But it is true that quantum mechanics is hard to understand. It's a very, spooky kind of thing. But just because quantum mechanics is hard to understand doesn't mean it explains everything else that's hard to understand. So there is this interesting thing of when people experience these things that they don't quite understand or hard to understand, it's common to say, well, it's just quantum mechanics. And that also has made it harder, I think, to have these interesting, careful conversations about them, because the scientists will look at it and go, well, no, quantum mechanics clearly has nothing to do with that, and then stop listening. But it doesn't mean there's something there's often something still interesting to talk about in there. It's just not quantum mechanics. And so that's where I like doing the physics of X.
What are your thoughts about a universal consciousness? Like we're actually getting our information from the same, I don't know what you would call it. I mean, other than that universal consciousness, and how you can
That
have a
is,
guy on one end of the world that gets the same idea as somebody on the other side of the world.
well, so I live in Southern California and I'm driving on the freeway constantly. And sometimes it moves and sometimes I'm parked on the freeway because it's not moving. And one of the things I think is really intriguing is we know we're conscious, right? And at least part of why we're conscious has to do with our brain. It may not be the total answer. There may be other pieces, but our brain clearly plays a role. Even if our brain is the only reason we're conscious because our brain has complicated interactions and a complicated structure, and it has a way of signaling, right? So it's interesting to me that this is one place where I do sort of challenge my scientific colleagues. Many scientists are of the view of, great, the human brain is conscious, that's it. But if somebody talks about a larger consciousness, it gets rejected right away as kind of very unscientific. But if I think about, society as a whole, it is a highly complex interacting system that is doing a lot of signaling back and forth, right? Now, I would argue the individual neurons in our brain are probably not necessarily aware that they're part of a conscious being, you or me or whoever.
Right.
So it's completely conceivable that there is a consciousness associated with all the interacting we're doing. And there's no reason we would necessarily be aware of it as individuals in that directly. But maybe that's part of what you're talking about, this sense we have because we're all connected that way. Likewise, let's face it, the universe as a whole is probably one of the most complex interacting systems there is. So even though I couldn't really tell you what it was like, and I couldn't prove to you it was there, it seems to me the logical conclusion is if a system is complex and interacting as our brain is conscious, it is likely that a system that is even more complicated and more interacting than our brain, the universe, is somehow universally conscious. Now, I don't know exactly what that means. I don't know exactly what it would look like, but it seems the more rational and logical conclusion than to conclude that consciousness only exists in this narrow space of interacting and complex and isn't a threshold. Like if you're sufficiently complex and interacting enough, you are now somehow conscious. So that's probably my most heretical stance from a science point of view. And because I'm really good at shameless plugs, it's exactly what I talk about in my book, Divine Science, Finding Reason at the Heart of Faith. So there you go.
Well, I mean, at one point in time, I think somebody came up with the idea of the telephone, the same time somebody else came up with the idea. And I mean, it was the same time.
Yeah. No, and in physics and science, the big one on that is calculus. Newton invented calculus the same time. And I'm totally drawing a blank on names because I'm old now. And my dad, who's a mathematician, is probably like going to be really upset that I can't remember his name. But you had two people inventing calculus at the same time, and Newton was a little bit better at sort of marketing and promoting his invention of calculus. So we think of Newton as the inventor of calculus at the moment.
Well, see, these things intrigue me.
Yeah. No, I think it's you're exactly right that these are some of the things that maybe are hints of these other sort of connections that you can't measure directly, but maybe we have indirect evidence for.
And I also wonder if we're not like a molecule ourselves. Just the whole planet is a molecule, and we're actually part of a larger system, just like all the atoms and stuff that make up your body. And that's why, I don't know, you can, I don't know. It's just one of those things that popped into my head is, are we really just small and what we see is, going to be relatively large, but we're actually small.
No, we clearly are small on the scale of the universe, and it's interesting what implications that might have, right? I think you're exactly right with that. Even just take it down to something you can see. Because I got really interested in free will, and I was reading different things. There's a philosopher who talks about, a corporation having choice as a corporation, and it's a choice that emerges obviously through the different interacting parts of the people in the corporation, right? But for many of the decisions that are made in a corporation, it's not like sometimes it's, oh, the CEO says, yes, we're doing this, but a lot of the decisions emerge out of all the interactions, conversations, and back and forth. And then the company moves in a particular direction, kind of like, our brain, all the stuff's interacting. We're getting all these inputs. There's all different levels in our brain interacting with all the other different levels, competing, the part of your brain that says, I'm hungry. I just want a cookie. The part of your brain that says, broccoli's healthier. And the other part goes, I don't care. And you end up eating a cookie, right?
I'm going to eat cookies after we finish this. You know that.
I know. I'm sorry. Yeah, I'm obsessed with chocolate chip cookies and foam. So what are you going to do?
Actually, I made Rice Krispie treats for my wife to take to her convention that she went to today, and there's some still left in there. I might have to grab those.
That's the way to do it.
So when you are on Ancient Aliens, what do you normally talk about?
So I describe myself as their friendly skeptic.
Mm-hmm.
And usually most of what I do is whatever is the relevant science for that. If I'm on the episode, I'll be talking about it. Because, no matter what you're doing, when you're talking about possible sort of alien visitations in the past, there's almost always some elements of science that are interesting to explain, even if the aliens weren't there or didn't come. And so I'll be talking about practical elements around space travel, because that's obviously interesting. But as I said, a lot of my interest is in material science. And so I study foams and bubbles as an example, but a lot of what we learn there applies to metals and ceramics and plastics and just a whole range of sort of material science questions. And a lot of what comes up with Ancient Aliens are, we found this artifact, or we found this thing, or we see this construction, could humans have done it? How would it work? Independent of who's doing it, how does it work? And so I'm just doing a lot of the science commentary. Occasionally I do, comment on how likely or unlikely I think something is. And I'm in the weird position of, there's always a chance aliens came in the past. I can't rule it out. I personally think aliens are out there, and I think it's kind of, excuse the pun, a space race between us and them as to who's going to actually get interstellar travel first, and whether we're going to meet them out there, whether we're going to meet them on their planet, or whether they're going to come here first. I feel like the universe is approaching that moment in time where life is discovering space travel, and we're all going to discover it kind of within 100,000 years of each other. We're all far enough apart that it takes about that long to travel anywhere. So, it's kind of going to be interesting timing to see who runs into who first.
Doing this show, I get to talk to so many different people, and I know a lot of the things that they talk about on there, that whether they're just kind of make it spread out and they, it's not for real. I don't get me wrong, I love that show.
Oh, it's a fun show.
It definitely is. I watch it every opportunity I get. I watch the reruns, the whole thing, and remember they did the one about the Star Child.
Yeah.
Well, I know the lady that owns the skull.
Oh, really?
Yes.
Okay.
And anyway, the truth behind it is it was just an abnormality, and I hate to burst people's bubble, but there's no Star Child. No, at least that skull is not a Star Child. It's just just something that happened in nature. And that makes it a little disappointing when you find out that they spread it out so long.
I think the challenge is from both their perspective of doing the show, but also just in general, and almost all of this stuff, whether it's aliens coming or paranormal stuff or other areas, there are real things there, and there
Yeah.
are real mysteries. And you know, it's often it's unfortunate, like I said earlier, that there are definitely things where, okay, it looks mysterious and we figure out what it is. And it's a shame if it keeps getting then portrayed as mysterious, because it causes doubt for the other areas where there still are open, interesting questions. So that's always a challenge. And there are things where it's just, yes, you can imagine how people would do it, but you don't have any evidence or know that they definitely did it. So there's still an open question. And so it's fun to speculate on.
Yeah.
You
Well,
know,
I don't think we should find out all the answers, because the fun part is the mystery of it and trying to get the
yeah.
answers. So I've always kind of said, maybe I don't want to know the real
Yeah,
answer.
there are some things. Well, but also there are a lot of things out there that people don't understand. I said this earlier, science is about experiments, and it's really good at what it does, which is designing experiments, making sure they're reproducible, and basically figuring out what things in life can we count on.
Yeah.
Like, it's about what can you actually predict. And if you actually can predict it, then you can make a technology out of it, right? And even a technology you can count on still glitches and does weird things. Like, we understand electronics really well, but phones and computers still do bizarre things just because bizarre things happen in the world, right?
Yeah.
And then there's this whole group of stuff, whether it's paranormal or aliens or other things, that are not easily doable from a science experiment strict point of view. And I would actually put them in the category of, they're much more like a crime investigation.
Mhm.
There is evidence, there are pieces, there are things you can gather, there's measurements you can make, but it's all about sort of one-time things and trying to build a picture from the evidence. And to that point, Kyle, you think about how many times in crime, right? We talk about it. It's beyond a reasonable doubt if it's criminal, if it's civil, it's, some doubt, but not a lot, or whatever the criteria is. A lot of times there's always going to be some doubt left, because you can't reproduce the event. You're just dealing with the evidence you have.
Yeah. Have you seen that camera that uses photons?
Which,
Because there's a camera that's out now. It uses photons to basically get a video or a picture,
yeah,
and it's freaking amazing.
yeah. So I think these are the ones. So what we're really getting to is, like, I mean, all light is photons, but it's like how individual a one you can detect. And with a lot of the new electronics, you can detect single photons and then build up an image over time or over different things. I think that's, I mean, and that just gets cheaper and cheaper, and more of us can use them. So yeah, it's super cool.
Well, one of my buddies who's on, he was on the new Ghost Hunters,
Okay.
and they used one of those cameras, and you could get a picture of a guy walking across the hall, and it was using those photons to pick up this image. And I thought, oh my God, that's probably the greatest tool that they've
Yeah.
created.
No, that's cool.
And I mean, there's all kinds of equipment that you can get off the internet, and I tell people, don't waste your money on a lot of it, like the
Yeah.
SLS camera and all that.
Yeah.
I got an SLS camera just because we were interested in how this thing worked, and
Right.
I can kind of tell you how it works. it well, real quickly, I mean, you know, they got those video games that they got the
Right.
camera, you can interact with it, and that's
Yeah.
kind of the basis behind these cameras.
Okay.
And
Okay.
you can pick up objects, and they will look like a figure.
Oh, okay.
Okay.
Yeah.
Now, one time I used it, and I can't explain how it did this, but there was a lady who, she said that her mother would come to her, and that was her spirit. And so we set up the camera where she said that she had the interaction with her mother. and there was a chair there. And she said her mother used to always lean over and just kind of rub her head while she was laying on the couch. And when we picked up a figure that was in the chair, I thought it was just the chair itself.
Right.
But then I said, can you wave? And the hand came up and waved at us. And I'm like, what the? And then you could see it lean over and act like it was rubbing
Oh,
somebody's head.
wow.
I can't explain that.
Yeah. No, I mean, that's that. I mean, and to your point earlier, there's just stuff out there that at the end of the day, it's there. It's a mystery, you know, and who knows, someday somebody might figure it all out and explain it, but it's certainly not going to be me.
I know that's right. Well, I wouldn't go out and spend a bunch of money on that stuff.
Yeah.
Use a camera and use a digital recorder. Those are about your best tools.
Yeah.
Although I have kind of become a believer in the divining rods.
Oh, interesting. Yeah.
Yeah.
But I assume that takes work and practice, though, I would think.
Actually, if you know, and I believe me, I have put my hands to where they won't move, and I'm not doing it myself because I know
Right.
subconsciously you can make objects move and you don't notice the small movements of your hands, but I can sit there and ask a question and they will move.
Oh,
Yeah. I mean, I know how they work when you're trying to find like a water line or a sewer
Right,
line,
yeah.
because you know you're building up friction in those pipes, and that causes the energy and makes those
Right.
things move. But to ask a question and say, you know, make it cross this way or make it go outwards, and it does it on its own. Yeah, that made me a believer.
Yep. No, that would.
So, what are your thoughts on ghosts and aliens and cryptids?
Yeah. So, we already talked briefly about aliens. I do think with aliens, you know, I think there's extraterrestrial life out there. It's evolving. We evolved here. It's going to evolve elsewhere. I just don't think we've intersected yet. I always find ghosts, you know, one of the more fascinating things as a physicist, because it goes back to why, you know, one of the reasons I've started thinking about kind of what I consider the interaction of the non-physical and the physical. Because with ghosts, you know, as you just described, you know, when people are looking into these phenomena, we're using physical tools to make physical measurements.
Mhm.
So that aspect of it, you know, is firmly within the realm of physics by definition, because we're doing physical measurements. And so then there's the question of, okay, well, what is the source of this physical phenomena? And I think that's where it gets more challenging. And to be honest, you know, I my answer often is I don't know. You know, this is an area where I just don't know. But I think there are some intriguing questions, and we've mentioned some of them earlier. You know, is this an example of, you know, sort of basically places where two different space times, you know, connect in some way? Is this kind of, you know, I'm trying, as I think through, well, what does it mean to have a boundary between a non-physical reality and a physical reality, right? Is this a way that those two actually interact? And what does it mean? You know, a lot of physicists will write about, by definition, the non-physical can't impact the physical. There's a sense in which I agree with that, and that's true. But I gave my example earlier of boundaries, right? You change the boundary and you change what a foam is. So can the non-physical and physical interact with the boundary between the two? And then by interacting with the boundary, interact with each other. You know, I think obviously, I think the question most people are interested in with ghosts is, are they actually somehow connected to a person who was alive, right? Because there's one thing to just have like spiritual, like ghosts in a non-person sense, right? I don't know if that word makes sense, right? But you know, you could imagine sort of paranormal experiences that don't have anything to do with a person who was previously alive. But the example you gave, like, are you experiencing the ghost of, say, your mother or your grandmother or, you know, an ancestor? You know, that I think it does intersect with this question of what is consciousness, right? And if you have an idea of consciousness being these, like the one philosopher I mentioned, these conscious objects that are fundamentally non-physical objects, but interact through the interface of the universe, you can imagine when you lose your physical interface, that's your body, the conscious object might interact through different ways, or there might be, again, boundaries you can have an imprint left on a boundary, right? A classic idea is ghost is an imprint left on the world somehow.
Yeah.
So, right, is there something that happens at the boundary between the physical and non-physical that even though there's no real connection to the person anymore, it's kind of an echo or an imprint or something like that. So if you had asked me, I don't know, 10 years ago, I probably would have been very strong. Look, I don't believe in ghosts. I think something real is happening, but it's a physical thing that we don't understand. So like, it's a real weird statement, right? When I say I don't believe in ghosts, it's not that I'm saying I don't believe something happened that I didn't understand. I just am pretty confident that the thing I don't understand is something physical. I think when we use the word ghost, it's only really meaningful if it also includes something not physical.
Yeah.
And I would say now, if I'm going to be honest about my thoughts about non-physical reality creating free will, then I have to take seriously that it might also have other effects. And what might those be? So that's kind of where I am at it right now. It could still be true that it is just physical things happening that we just don't fully understand. And, if you have, it's sort of like, when you look at all these cool optical illusions, right? Where like you look at the pictures in an old lady or a young woman. I don't know if you've ever seen that optical illusion.
Yeah.
Where it flips back and forth, right? Your brain clearly takes stuff and makes it what you want. So it could be that these are real physical things that are happening in weird ways, and they're just close enough to a person or somebody waving their hands or words we're used to that we can't help but have our brain make it be those things. But that's not nearly as much fun or exciting.
Right. Well,
but I think at the core is what you said, Kyle, right? There's still a mystery. And so you have to ask yourself, what are the interesting possible things it could be? So what's the next question you would ask and do if that's what it is?
well, I mean, there's that phenomenon, I think they call it, is it pareidolia, where you see faces in objects or, designs and things.
Right. Yeah.
And a lot of time I can, kind of poo-poo the idea that, oh yeah, that was a ghost. It's just your mind seeing something there. I as much as I believe in ghosts, I'm also the biggest skeptic in our group.
Right.
So I could usually explain things away. I mean, high EMF readings can actually cause illusions and I went to a house one time and EMF detector was just nuts. And I went up in the attic, and I kid you not, I don't know if you remember, but they used to put this almost like a cloth material over wiring.
Oh, yeah. And then
So,
it would catch on fire.
Yeah. Well, the people who owned the house had cut away a section of it and wrapped wires around it and had a light in the attic, and it was feeding off of this wire.
Oh, wow.
So the EMF, no wonder it was going nuts, because you had this exposed wiring.
Yeah.
And to top it off, they had a transformer which was literally over their backyard. I mean, you could go outside, take a stick and hit it,
Yeah.
So they're getting all this EMF going on, and I think that's where they were getting their phenomena.
Yeah.
But we did an investigation, and it was in Spring, Texas, and the house, the property, it had pretty good history to it.
Yeah. And I think that's the thing. I describe myself on Ancient Aliens at times as the friendly skeptic.
Mm-hmm.
I mean, I know where my skeptical boundaries are, but I also recognize that there are just real things that are happening that we just really don't understand. And it's interesting to think about, well, what could we be missing? What could be the pieces that are out there?
This house, there was a time when I went upstairs by myself, and I'm walking around, and we had the video camera going, and what looks like a moth flies in and it kind of disappears behind me. Well, I just said it's a moth. It's just a moth.
Right.
But at one point, one of the girls on the team had taken her phone and she was videoing the video so she could put it on Facebook.
Right.
And anyway, we watched that thing, I don't know how many times. And then somebody actually noticed, and you can hear it. It actually, when you see that thing fly in behind me, the voice says, "That was me."
Oh, interesting.
Yeah, nobody else was talking at that time, and that's when it, right?
Yeah.
So,
yeah, no, it's just I get you. It's you just don't. Yeah, what do you do with that?
And isn't it true that you can't destroy energy? You can just transfer it.
And that is one of those interesting things. Yeah. So the language, if I want to be really picky, energy is a state of things, right? It measures the state. And so if a thing goes of lower energy, something else has to become higher energy. So energy is always, in the overall system, energy is always conserved, which means it's just changing form. It's not ever disappearing completely.
Well, my theory is, I believe our bodies are made of energy.
Yep.
And so when you die, wouldn't that just kind of transfer?
And that's exactly my earlier analogy of like an electron and a positron. They come together and they make two photons or light. There is something about us, right, that is still there after we die. And the interesting question is, what does that mean physically? Is it really just, is it all physical sort of energy and vibrations and quantum wave function stuff? Is there a non-physical component to it as well? But again, it goes to in my mind, right, on one hand, yes, what we see is the dead body that doesn't seem to be doing anything. So one could imagine, being very crude, that the natural conclusion is, when you die, that's it. It's all over, right? There's nothing else that goes on. But again, if you're not doing the measurement right, when a positron and an electron annihilate, what you just see is there's no longer a positron and an electron. There's nothing there anymore if you don't have the tool to measure light, right? And so just because the body is not functioning and we can no longer measure other stuff doesn't mean there isn't other stuff. My other analogy is if you think of, your computer screen and mouse and keyboard and all of that is kind of your body, and you couldn't see the hard drive and the processor, right? If the screen all went dead, you would assume there's nothing left there, right? But if that hard drive and stuff went somewhere else and did something, right, you'd kind of still be doing stuff and you wouldn't know it. And so I think of, our body and stuff as the screen and the mouse and the keyboard. And yes, when it's dead, and it can't interact with what it was interacting with before, but it doesn't mean there's not other stuff that was part of that that's now still going.
Well, I had a TV that there was a picture that kind of just froze,
Yeah.
And you couldn't turn the TV off. And then once it finally kind of went out, the imprint of that picture was still on the screen.
Oh yeah. Yeah. No, those things happen. I still remember the first TV we owned as kids. It makes sense. TVs died. They had the picture tubes, right? And we were watching TV and we watched the screen go black at the edges and shrink down as the tube burnt out to a little dot. And we're all standing there going, what just happened? And my parents were like, well, I guess we need to get a new TV.
Yeah, I remember those days. God, we're old.
I know. But better than the other options, Kyle.
Yeah, this is true.
Yeah.
When does your podcast usually come out?
So we come out on Wednesdays, usually is when we drop. We're in 7th season now. We just started it. We started a week or two ago with, we did a really fun thing. We did our superhero draft. So instead of talking about a show, we it was in honor of fantasy football. Daniel J. Glenn, our organizer, he does fantasy football. I do fantasy baseball, but but we each picked a superhero team, and obviously mine was the best, but I had the surprise pick. I declared Bugs Bunny the ultimate superhero and picked him for my team. Going back to our Saturday morning cartoon theme. And so, yeah, so we do that. And so that's a lot of fun. And like I said, people can get my book. It's on Amazon. It's both in print and, for the Kindle and digital. And so, and people can just find me on Twitter and Instagram if they want, at Dennin Michael. You just flip my name. And so I do try and tweet fairly regularly. I'm not quite a social media, mogul yet, but I'm getting there.
Well, if you can't make me fly and all that, be super strong, can you make me those bracelets like Space Ghost had?
Okay, well, that will work on next. I don't have that solved. I have to admit, I'm trying to still build my own lightsaber, but a bracelet like Space Ghost is another good idea, Kyle. I like that.
Well, the next time you have a superhero discussion, you got to let me know. I'd love to sit in on that.
Sounds good. Okay.
And you always pick Batman.
Oh, I have to admit, I'm a Spider-Man person.
Oh, I love Spider-Man, but
Yeah.
Batman can beat everybody.
No, Batman is awesome. I go Spider-Man slightly ahead of that. So Spider-Man was my lead pick, but I respect Batman as a pick. I respect that.
Okay, well, and make me some web shooters too then.
Yep. Yep. We'll get some web shooters going.
Well, Michael, thank you so much for coming on. This has been really enjoyable.
Oh, great to be here. I loved it. It was a fun conversation.
And I'd love to have you back again someday.
Sounds good. Yeah, let's stay in touch.
Definitely. And, I want to thank all of y'all out there. If you happen by the show and this is your first time, I appreciate you stopping by, and I hope you'll come back. Hit that subscribe button. If you're a regular, you know how much I appreciate y'all. It's because of your support that I get to do this. I mean, how great is it that I get to sit and talk about superheroes and, ghosts and all these things. So until the next one, everyone, please take care. Be kind to one another. God bless and peace.
Po boy.